a universe in motion. Planets orbiting stars, stars drifting through galaxies, energy transforming, never disappearing, only changing form. Everything moves, everything follows rules. But what if the rules themselves had a hidden pattern, a deeper truth, buried beneath equations, invisible to the eye, yet governing everything we know about reality? For centuries, the greatest minds tried to understand why the universe behaves the way it does. They found laws, they found formulas, but they couldn't answer one haunting question. Why do these laws exist in the first place? And then, someone found the answer. Not in a laboratory, not through machines, but through pure thought, through patterns so elegant, so precise, that they revealed a secret woven into the fabric of existence itself, a discovery so profound it would reshape physics forever. And yet, the one who uncovered it was barely seen. This is Forgotten Minds, where brilliance flickers in the shadows of history, and some of the greatest revolutions were carried out by those the world refused to recognize. She was born in 1882, in Erlangen, a small city in Germany, into a family where knowledge lived in the walls. Her father was a mathematician, respected, accomplished, part of a world that, at the time, did not expect daughters to follow in the same path, but she did. From an early age, numbers made sense to her in a way words often didn't. Patterns weren't just logical, they were beautiful. But beauty alone doesn't grant permission. At the time, women were not allowed to formally enroll in universities in Germany. So she listened, literally. She attended lectures unofficially, sitting quietly, absorbing knowledge she wasn't officially allowed to receive. No recognition, no enrollment, no certainty that any of it would lead anywhere. But she stayed. Because for her, this wasn't about permission, it was about understanding. Eventually, the rules changed, slightly. She was finally allowed to study formally, and she earned her doctorate in mathematics, an achievement that should have opened doors, but instead, it revealed how firmly those doors were still closed. She worked, she researched, she taught, but not under her own name. At one point, lectures she prepared were delivered by her father, because a woman standing at the front of a classroom was still unacceptable. Imagine that. Doing the work, solving the problems, advancing the field, and then watching someone else receive the acknowledgement simply because of who they were. Years passed like this. Quiet contributions, invisible effort, until something changed. She moved to Göttingen, one of the most important centers of mathematics and physics in the world at the time. It was there that she crossed paths with giants. David Hilbert and Felix Klein, men whose names carried weight, influence, authority. They saw something others had ignored. Genius. They invited her to work alongside them. But even then, acceptance wasn't simple. When Hilbert tried to secure her a formal teaching position, the faculty objected, not because of her ability, but because of her gender. One argument reportedly went like this: "What will our soldiers think when they return to university and find themselves taught by a woman?" Hilbert's response was quiet, but devastating. "This is a university, not a bathing establishment." And yet, even with his support, she was denied. So she taught anyway, unofficially, unpaid. Her lectures listed under Hilbert's name, her ideas spoken through someone else's authority. But something extraordinary was happening beneath the surface. Physics was in crisis. New theories were emerging, strange, complex, challenging everything scientists thought they knew about reality. At the center of it was a revolutionary idea known as General Relativity, developed by Albert Einstein. It described gravity not as a force, but as a curvature of space and time. Beautiful, powerful, but incomplete, because something didn't add up. The equations worked, but they seemed to violate a fundamental principle: the conservation of energy. Energy should never disappear. And yet, within this new framework, it appeared to. Physicists were puzzled, confused. Some even doubted the theory itself. And that's when she stepped in, not with experiments, not with instruments, but with something far more precise: mathematics. She looked at the problem differently, not as a failure of physics, but as a question of symmetry. What if the laws of nature weren't just rules, but reflections of deeper symmetries? What if every conservation law, energy, momentum, motion, existed because something in the universe remained unchanged? She worked through the equations, carefully, patiently, quietly, and then she found it. A connection so fundamental, it changed everything. Every symmetry in nature corresponds to a conservation law. If time behaves the same today as it did yesterday, energy is conserved. If space behaves the same here as it does there, momentum is conserved. It was simple, elegant, unavoidable, a truth hiding in plain sight. Today it's known as Noether's theorem, and it didn't just solve a problem. It became one of the most important principles in all of physics. A foundation, a bridge between mathematics and reality itself. Albert Einstein himself recognized its significance, later describing her as one of the most important creative mathematical geniuses since women's higher education began. But recognition did not come easily, even after such a groundbreaking discovery. Her position remained unofficial for years. She continued teaching without pay, without title, without security. Only later, much later, was she finally given a formal role. But even then, it was limited, underpaid, conditional. And just as stability seemed possible, everything changed. The year was 1933. Germany shifted. The rise of Nazi Party brought with it policies that targeted those who didn't fit their ideology. She was Jewish, and that alone was enough. She was dismissed from her position, forced out, not because of her work, but because of who she was. Once again, she became invisible. But this time, it was dangerous. She had to leave, to abandon the place where she had built her life, her work, her identity. She migrated to the United States, starting over in a new land, a new system, a new uncertainty. She found a position at a small women's college, not the grand halls of Göttingen, not the epicenter of global mathematics, but a quieter place where she continued to teach, to think, to inspire. Even there, her brilliance was undeniable. Students admired her, colleagues respected her. But the scale of her recognition still didn't match the scale of her contribution. And then, in 1935, at the age of just 53, her life came to an abrupt end. A complication following surgery. Sudden, unexpected, quiet, and with it, the world lost a mind that had reshaped the very foundations of physics. But here's the unsettling truth. Her work didn't fade. It grew. Over time, scientists began to realize just how essential her theorem was. It became a cornerstone of modern physics, used in everything from particle physics to cosmology, from quantum mechanics to field theory. Her ideas were everywhere, even if her name often wasn't. For years, she remained in the background, mentioned briefly, acknowledged quietly, while others stood in the spotlight. But slowly, that began to change. Historians revisited her story. Physicists spoke her name with the respect it deserved. And the world began to understand that one of the most important minds in science had been hidden in plain sight. Not because she lacked brilliance, but because the world wasn't ready to see it. Her life leaves behind a question that lingers. How many breakthroughs were delayed because the person behind them didn't fit the image the world expected? How many voices were softened, silenced, or redirected before they could be fully heard. The woman who changed physics forever was never truly invisible. The world simply chose not to look. Her name was Emmy Noether, and if her story stayed with you, if it made you feel the weight of what was almost lost, then help keep it alive. Subscribe so these forgotten voices continue to rise. Like the video, so more people can hear what history tried to quiet. And if you want to explore the truth behind her work, the references are waiting for you in the first pinned comment, just beneath the surface.